So this is a DevOps conference. Let me start with a quote from Hannah Foxwell. Developers don't care about production, ops don't care about shipping new features, and no one cares about security. This is a security-related talk, and I will tell you why you should care about security, and it is actually not that hard to cope with security in a DevOps environment as well. Let's also make sure that we have the right mindset. Quote from Jesse Frizzell: hire the people who will automate themselves out of a job and just keep them giving new jobs. That's basically what we do, and I very much like this tweet. Doesn't mean that we're machines, but we know how to tell machines what to do. And there's another quote from Gregor Hoppe, which basically says the same thing: automate everything and make those parts that can't be automated a self-service. So let me start with infrastructure as code. The infra as code guy already had his talk, and he's the expert. I'm not the expert, but I'll try to summarize what that actually means. It means, in my opinion, that you can describe your infrastructure in text files, YAML files, whatever, and that you keep those text files within version control. But not only that, you also have tests for your infrastructure. You have automated tests. So you build on those tests and you have version control, but that's still not enough. You have a continuous integration environment as well. And this CI environment will make sure that all those automated tests are executed all the time when someone pushes or checks in something to master or to the main or to the version control system. And we can push that even further when we have continuous integration in place. There's continuous delivery, which tells you to use deployment pipelines, which tells you how to bring changes, even infrastructure ones, into production. Now, let's consider you've successfully introduced infrastructure as code in your company. How did you deal with secrets? What are secrets? There are very different types of secrets, but it's essentially information that it's within your configuration that has sensitive data. So it can be a database password, for instance. It can be an API token, but it can also be more infrastructure related, like SSH keys or TLS certificates. So what do you do with those secrets? Solution attempt 1. You make a big fence around your version control. Is that a good idea? Guess not. Why? Well, first of all, open source is a good thing, and if you can't do open source, it's at least a good thing to have your source available for all your developers in your enterprise. So debugging will be a nightmare if it's closed source again. And the second problem is you can't even grant read access to your repository because you would expose your secrets. So I think we all agree that this is not really a good solution. What can we do? Well, we can do that. We can use a separate version control for our secrets. We have our code and non-sensitive configuration in one repository, and we have secrets in the other one. Now, this introduces new problems. If you're working on the head of both of them and you don't have releases, it's pretty easy. You know you have to work on the latest version. But if you have releases, for instance, and some companies still do, at least as I know, it will be difficult to keep those two in sync. How to sync those two? Make sure that they are consistent. And there's another problem. Your secrets may leak. What does that mean? Well, if somebody clones, you have Git, of course, somebody clones the repository, he or she has all the secrets in a copy, and not only that, but with the whole history. So it's very difficult to control and build a system where your secrets are protected accordingly. So also, let's agree on that. It's not really a nice solution, and the question is, can we do better? And of course, we can. Encryption. You can use encryption and encrypt all your secrets within your version control using GPG or whatever tooling you'd like. There's even decent tooling. I've mentioned them on the bottom. There's, for instance, Blackbox or Gitcrypt. Nice, simple solution. We already heard about the Docker credential helper before. It also uses encryption. What's the problem with this approach? First of all, what do you do with your CI server? How is it able to decrypt secrets if it doesn't have a GPG key? You make it a trusted entity. Are you willing to do that? I mean, everybody who can log into the CI server now potentially can see some sensitive data that he or she is not allowed to see. And the other problem is that all your passwords are always one other password, or all your secrets are always one password from being decrypted. So it only needs one decryption key, and you can decrypt everything. That's the next problem. Can we do better? Yes, we can. We can use a tool for secret. And I'm going to show in the rest of the talk how you can use Vault and the features within this tool from HashiCorp, which is essentially nothing else than a key value store for secret, how you can deal with a secret in a more DevOps, in a more DevOpsier manner, I'd say. But before I start with this one, I will start with some introduction. I will start with identity and access management. In my opinion, identity and access management has like three main entities. There is identities representing users, real users, but could also represent apps or services or machines. Then on the right side, there are permissions. You also hear the term role-based access control or access control list. Within Vault, they are called policies. And then we have authentication methods. In order for an identity to become an identity and representing a user or a machine, you have to authenticate. Well, the most widely known and used one is username password, of course. Could also be certificate, could also be a hard token, could also be delegated to a directory service like LDAP, and then there's one other special auth method which is named app role, and it's a concept from Vault. And I would say that if you want to automate secrets, it's like the most important concept that you have to know about Vault. Vault has many more features. I'm not going to sell Vault to you. I'm just going to tell you how you can automate secrets management. And app roles play an essential role for that. So how does it actually work? This is a basic workflow, so this is the basic version. I will continue with the more complicated and advanced one, and it still has manual steps in it. But let me start with this basic workflow first. So on the left-hand side, you still have an administrator who does some things. So first of all, he or she creates a policy and an app role. So the policy, remember, that's like the permissions which are then associated with the app role. Next step is to get a role ID. This is basically a UUID, and the admin will also create a secret ID. What's a secret ID? You can think of role ID and secret ID like like a username password login for machines. It's both of them are UUID strings. Once both of them are created, they are being delivered to the app. So there's step 4 and step 5, delivering the role ID and the secret ID to the application. Remember those two steps because they are going to be important as well. Now, the application has the possibility to do an app role login. So it will take the role ID and the secret ID, and it will get an authentication token in return. And with this auth token, the application can then do further operations with Vault, like reading secrets that the application is allowed to read. Demo time. So I will demo to you the steps, how this is going to work. Vault itself is basically just a binary, a Go binary. The server and the client are the same, and I will lead you through those steps. In tab 1, I will start a dev server, a Vault dev server. So the dev experience is also quite good. And then the second tab, in the second tab, I will do the operations that I've shown that an administrator would do. And then in the third tab, I would do what the application would do. So let me start with this. You can see this is the Vault version I'm using, probably not the newest one. There's probably already a newer one. And I'm going to start this dev server. It already started. It will tell me some information like where is it running, and it will give me an environment variable that I will be copying, which directs to the Vault server. So one environment variable here. I will then do some commands. This will already work because the root token is being stored in a local file, the .vault something, in my home. And I can see that the policy is the root policy, so this is like root access on a Unix machine. And I will now, for test purposes, I will now put a secret under the path secret for my app with the key my secret, and the value is very secret. And you can see it has been, that operation was successful. So I will try to read it and show to you that it's being stored into Vault. Now I will enable the app role auth method. So this is not enabled by default. And I will create a policy. Policies are written in HCL, which is a HashiCorp configuration language, I guess. And it will tell, yeah, well, you are allowed to read a certain path. And I will tell Vault to create a policy based on this ACL file. There you are. That worked as well. So now I'm going to read the policy as well, and it's stored within Vault. Now I'm going to create the app role and associate the policy with it. That worked as well. And I'm going to read it again. There we have it. Now, next two steps are like reading the role ID and creating a secret ID, which are both two Vault commands as well. So here's a subpath for reading the role ID. That's my role ID. And I'm going to generate a secret ID. This is a recorded demo. Because I don't trust the demo gods. Okay, so now I'm in the third tab. What I'm going to do is I'm going to do an app role login with the credentials provided from the second tab. So I'm going to take this role ID, and I'm going to take the secret ID, which is here. And these are secrets as well. Now, the login worked okay, and I got a token in return. I will put that in an environment variable as well, which is named Vault token. So the Vault client will then read the token from this environment variable. There we are. And I will do a token lookup again, and there you can see the path is like app role. I have a policy, my policy, and I have metadata which tells me it's my app role that I've been looking up. And now I'm trying to read the secret that I put into Vault before, and that should work as well. There you are. What if I'm going to try to read the secret of another app? I get a 403. Okay, so that seems to work quite nicely. There's one last thing I want to show to you. There's also a UI. So there's not only a command line, but there's also a UI within Vault, which has been open sourced only recently. And I'm going to use the root token. The root token is, I mean, in production you wouldn't use a root token, or only in special cases. So this is really only for demo purposes. And now here I have a tab with the secrets, and I can go into this path and show you the secret again. So here's my very secret. And then there's another tab for the policies. I can also show the policy that I've created before. Yeah. And that's basically it. That was my demo. Now, there's a chicken or egg problem with secrets. What's the chicken or egg problem?
We have to store the new secret.
Sorry?
We have to store the secret for the app.
Yeah, exactly. So remember the last slide when I said, yeah, remember those two steps, like how to deliver the role ID and the secret ID to the application. It was still done by an administrator, so this is not really being automated. Now consider the problem. You have to deliver a secret in an automated way to an application, but you have to do it in a secure manner. What are you going to do? You could encrypt it. But the problem with encryption is you need some secret to decrypt it. So this is the chicken or egg problem. And there's actually also a solution to that. And it's you use two channels to deliver your secret. So you split up your secret. In this case, it's the role ID and it's the secret ID. And you use two different channels to deliver this information to your application. So now it gets a bit more complicated. This is app role on steroids. On the left-hand side, you see the channel for the role ID. There's still an administrator or a developer involved, and this role ID is going to be baked into the machine image. Could be a Docker file, could be a VM image, doesn't matter. And you're going to use a trusted entity, Terraform for instance, to deliver this, to provision this image to the application. That's the left-hand side. On the right-hand side, you have a secret ID. But not only a secret ID, it's a wrapped secret ID. What's a wrapped secret ID? It's basically a reference to a secret ID so that the secret ID doesn't have to leave Vault at this time. And you're going to use another trusted entity. Could be a configuration management tool like Puppet, Chef, Ansible, whatever. or it could be also an orchestrator that delivers this wrapping token to the application. And now the application is able to first unwrap the secret ID, so it gets the real secret ID, and in another step, it can do an app role login and do further operations again. So I won't say it's easy, but if you try to follow the steps, I think it makes sense. Those two pictures I've shown are nothing more than what's on the Vault website, but I couldn't have drawn them better, so that's why I was using them here as well. Now you might wonder, how do Vault and Kubernetes integrate? There are different types of integration. First of all, Vault itself has a separate authentication method. There you basically establish a trust relationship between your Kubernetes cluster and Vault. And with this, you're able to use a Kubernetes service account token to do an authentication with Vault. So basically no app roles involved. That's one possibility. The next possibility is to use a third-party tool from Boostport. And it basically uses app roles within a Kubernetes environment and makes the usage a bit easier, or the experience a bit easier. And then there's secrets. Secrets is a plain Kubernetes feature, and there's nothing wrong with that. You can also use plain secrets and not use Vault at all. This basically depends on your requirements, like if you want to keep all your secrets in one place, or if it's okay to have them within your Kubernetes cluster. So different types of integration really matters what requirements you have. So now I'm a bit ahead of time, but I made my point. So let me come to the conclusion. First of all, security, in my opinion, is difficult to automate. It's can be hard. But there's good news. Secrets management itself, which is like a subset of security, this one can be automated. Be aware of the chicken or egg problem with secrets and how to solve it with 2 channels. And my last point is to advise you is to give Vault a try. So yeah, there's now enough time for questions.
Yeah, if there is a question. If not, there will be a break. Can you? Johann, I'm very glad you talked that open about those secrets, you know. Nice. Many thanks. And as we said, there will be a short break.